I'm going to go ahead and let each of the panel members introduce themselves. Try and keep them to about 2 to 3 minutes. Give us a little bit of background on who they are, what they do, and what the perspective that they'd like to bring to our panel session today. And then I'm going to bring it back. We're going to go through some prepared remarks that I brought with me, but we want to make sure that we're encouraging audience interaction. So please be prepared. We're going to open up to the floor for questions of this esteemed panel. And then if we have time, I'd like to bring it back. I think we've got a pretty fun question that we'd like to wrap it up on if we can. And again, it should send us off to go grab a couple of drinks, and we'll look forward to seeing you out there. So with that, I want to introduce first to my left, Mr. Ron Gula. He's he is the president and co-founder of Gula Tech Adventures. He was the prior CEO and co-founder of Tenable Networks. And so if you could go ahead and say a few words.
So great to see everybody. I like to see so much interest in artificial intelligence and machine learning. I'm going to be a little bit of a contrarian in that I haven't just seen it deliver in cyber. I ran Tenable Network Security for about 15, 16 years. Every year I had somebody call up and say, we can predict zero-day vulnerabilities using AI and machine learning. We can predict the next generation breaches. And now that I've transitioned from being a tech leader to being a investor, it's, I literally get people saying they can predict all these different things. And there's a lot of snake oil out there. You shouldn't lose heart. You should just buyer beware. There's a lot of interesting technology. I'm actually sitting next to some experts in the space, but a lot of times in cyber, when people market AI and machine learning, they really mean advanced reporting or maybe crowdsourced sharing and things like that. So I'm looking forward to kind of dive into that a little bit. Thank you.
Very good. The old challenge of marketizing versus actual capability, that is absolutely rampant in this field. And so if we go down the line there, we've got Dr. William Vanderlinde, Chief Scientist, Intelligence Advanced Research Projects Activity, otherwise known as IARPA.
Mm-hmm. Yeah, so you're probably wondering what IARPA is. Rhymes with DARPA, sounds like DARPA. In fact, we're modeled after DARPA, the difference being DARPA's focus is on the Department of Defense, whereas IARPA's customers are the 16 agencies that comprise the intelligence community. So we use, I'd say, machine learning in probably 60% of our programs, one way or another. It's very, very valuable, particularly in looking at video and image analysis and things like machine language translation.
Very good. Very good. And so if we keep going down the line, last but not least is Mr. Rich Frederick, Senior Director, Cybersecurity Analytics, Micro Focus Government Solutions. And so, Rich, if you could provide some perspective on your history in this area.
Thanks, Chris. Welcome, everyone. My name is Rich Friedrich, and I'm leading our cybersecurity activities within Micro Focus Government Solutions. Now, who in the heck is Micro Focus Government Solutions? I have a long and, I think, a fairly esteemed career at Hewlett-Packard. I ran a big chunk of the research labs there in the last decade, focused on big data analytics and machine learning, artificial intelligence. I took that capability to our enterprise security products, where we're building it into a lot of the capabilities to try to address some of the things that Ron just mentioned, and we'll come back later on, because there's a lot of snake oil in this business. And then lo and behold, we got spun merge out to this new company. So we are now the 7th largest pure play software company, which is kind of nice, not being part of the HP hardware mothership. We can actually do things from a software point of view. And we have a range of offerings, from everything from IT management to security management to to probably the best big data analytics platform. And we'll talk more about what all that means related to machine learning and artificial intelligence.
Yeah, I think the perspective is going to be fantastic given the history in the field to understand where we are today. And so we have a topic today that I think is sufficiently broad. It's also potentially polarizing. And so in order to sort of set the stage for the discussion that we're going to have, I wanted to make sure that we were all on the same page. Again, we're talking about expanding the role of artificial intelligence and machine learning in both the private and the public sectors. And I thought if we defined it together and then had a conversation around it, it might make sense. And so always look to the National Institute of Standards and Technology. They define artificial intelligence as computer systems that think and act like humans, that think and act rationally. And so in other words, we're building machines that can understand human language, they can perceive and they can sense, and they can learn from experiences. And now when we talk about machine learning is really a subset of AI. It describes a machine's ability to infer and deduce based upon information that it receives. And so again, in other words, when you're talking about machine learning, it's the machine's ability to learn like a human without otherwise being explicitly programmed to do so. And so you think about this in a number of different ways. We've all seen a number of different movies where this can go awry, but there are a number of advancements in AI and machine learning that are offering a lot of promise in the way that we live and in the way that we work. It also introduces some serious societal and political issues. And so we're going to try and hit this, I think, from a sufficiently broad area again. And I want to start, again, I'll go down the line this way with Mr. Gula here. I want to start in the present. Understanding your role today, evaluating emerging technologies from an investment perspective, I'm sure you get to see a little bit of everything, right? And so where are we today in the advancements of artificial learning and artificial intelligence or machine learning?
So if you go to cybersecurity conferences like the RSA conference or Black Hat, you're going to see 800 companies or so out there. And I think this year you're going to see a good percentage of them say they have some sort of machine learning built in. The important question is how are they applying machine learning? I'll talk about AI in a second. There's some really big problems in cyber we haven't solved yet. For example, malware. We started off with definitions. We don't have a definition of what malicious malware is. Malware tries to look like regular software more and more every day. So somebody who says, hey, we've taken a big pile of malware and another big pile of good software, and we've trained an AI to recognize both of these different things, well, maybe it's not an AI, maybe it's machine learning, maybe it's statistical, maybe it's marketing, but I'm not so sure that that was a good thing to do from the beginning. And I think one of the big issues we have with the current state of AI and machine learning is how are we training these things and what are we training them to do when there's so many different problems out there. And as an investor, I try to kind of figure out through that. The design pattern we see is people sense, maybe they have intrusion detection or metadata or Twitter data. They dump it into something called Elastic. They do machine learning and mix threat data into it. And I've got probably 200, 300 pitches like that are not fundable companies because the market's figured out that doesn't really work.
Yeah, you really can't go to RSA anymore without someone having some form of machine learning in their marketing message. And again, I think it introduces an interesting concept around trust with the machine as you're teaching it how to learn as well. And so, Bill, in your opening remarks, you had mentioned that about 60% of your programs, I think you had mentioned that you're working with today, leverage some form of artificial intelligence. Again, from your perspective at present, where are we today and what benefits are we seeing from that?
Well, let me just mention one of our programs called Babel, which had to do with machine translation. And to give you some perspective here, linguists have spent decades studying the structure of language, developing algorithms, making sort of incremental progress. 1 or 2% improvement in word error rate was considered a big deal, where you get a PhD thesis from that. In the Babel program, we had labeled data sets that were used to train recurrent neural networks, and we achieved in the range of 10 to 15% word error rate improvement, which is really dramatic. That makes an immediate effect that people can see right away. So as far as I'm concerned, any place we've seen large data sets that we can label, we've been able to really leverage machine learning.
And so are you seeing the advancements in compute capacity and things like that sort of lending towards an accelerated use of artificial intelligence against those known data sets?
Yeah, that's certainly an important issue, and it can be very, very computing intensive to do the training, whereas the inference can be much more expeditious.
Okay. And so if Rich, I could have you round out the topic. Again, given the prep call, your experience at HP, just moving from innovative project to innovative project and the exciting opportunities that you walk through, maybe you could provide some perspective on how you've seen it evolve to where we are today.
I think a really good question is first trying to understand essentially what it is we're talking about when we talk about AI or machine learning. I spent a lot of time in Silicon Valley. So the West Coast talks about this whole field as artificial intelligence. And it seems like the East Coast talks about machine learning. And perhaps that's because the whole MIT fiasco of the 1970s and 1980s, when there was a belief that AI was right around the corner and we saw what happened. It seems like the East Coast remembers that, so I tend to hear very little AI described here. It's usually almost machine learning. But But so it's just interesting observation. The second thing I think that's really critical, Bill touched on this a little bit, and so did Ron. Why are we even here today? There are places where machine learning or artificial intelligence are making a big impact. Object identification with respect to images, text processing, speech recognition. There's some really nice breakthroughs in the last 10 years. And why is that? It's because we have these huge data sets that are labeled. In other words, we know something about the ground truth. And we have processing power we didn't have a decade ago. And I think it's really important to keep that in mind. When I was doing neural networks, before some of you were even born, oh my God, there's really very little difference in that algorithm back in the late 1970s compared to what is today. The difference is these big data sets and this computational power. And so you see some of this nice improvement in some areas, but there's areas where we still have a long way to go. Cybersecurity, for example. We have a long, long way to go. But I think what is interesting is that just this week, just as an example where machine learning can apply to cybersecurity, is that the DHS released a US cert within the last 48 hours on yet another North Korean malware attack, okay, the Fall Chill. And some of my team has some very big data sets, hundreds of billions of events. And by using our Vertica data platform, which has some built-in machine learning algorithms, and what I mean by that is some of those statistical techniques such as k-means clustering, feature extraction using random forest, et cetera, we could find in that 100 billion events a set of these patterns that clearly indicated that those attacks were occurring in our customer sites. And we could do that in a couple of minutes, which I think is really powerful when you're thinking about that size. So I think machine learning is starting to make a presence in things that aren't just speech and video and imaging, but we still have a long ways to go.
So as you talk about the advancements moving in that direction and the ability to apply it to more and more data sets, I don't think I could host a panel on artificial intelligence and machine learning without talking about how do we use this technology, and maybe I'll just throw this up there to whoever wants it first. How do we use this technology in government to balance against the human capital shortage that we see where, I was reading an article, Lieutenant General Jack Shanahan did a keynote at NVIDIA's GPU technology conference, and his clear theme over and over and over again was let the tech do the mindless work so the humans can focus on what they do best. How are you seeing this technology being applied in government to do that today?
If I can take that.
Sure.
So in many ways, we're at the bottom of the waterfall in cyber, right? Rather than fixing our networks and fixing our security and having good cyber hygiene, we're trying to solve it down at the bottom of the waterfall where there's a lot of stuff. That's why there's a big shortage. So most of what we're seeing today is things that make our jobs easier. And if you walked into a security operations center, you're going to see a lot of tired people who are drinking a lot of caffeine, doing what looks like very monotonous things, looking up IOCs, people who might not have access to the database. Is this IP address good or bad? They're going to do a lot of grunt work. So we're seeing a whole industry of people using machine learning and AI to kind of automate those things, but also automate the sharing of those things and sharing of that kind of knowledge. Help me determine what is bad so I can do more with what limited time I have. That's kind of where we're at today. Where we're not is an AI that kind of looks at all the data present and says, okay, Mr. CEO, if you don't want to be Mr. CEO from Equifax, here's the top 10 things you need to do. We don't have a product in that space. We don't have a solution in that space. We don't even have a government program going down that road in that space, even though we have a data set from the Continuous Diagnostics Monitoring Program that we could leverage to do something like that.
So Bill, if I could take that thought and extend it just a little bit further, I'm wondering if IARPA is seeing any progress in one of the biggest challenges in trying to label these data sets is the amount of time it takes a data scientist to spend in the minutia before they can perceive any sort of analysis of that data. Are there programs that you're working on that are helping to reduce the amount of time so that we can focus on areas where we can have a profound impact?
Yeah, we actually recently hired someone who's going to be focusing on the issues around labeling data sets, and that I think will be an important facilitator for other things we're doing. But just to follow up on what Ron said, I think for years, artificial intelligence was stuck in the mode of thinking we want to train a computer to think like a person, and that ended up not being that productive, whereas what has been productive is training them to do things that are tedious or difficult for people to do that can assist us, such as, say, there's more and more video cameras monitoring airports and other places around the country, but actually having someone sit there and watch those video cameras is just mind-numbing and ineffective. So one of our programs is developing a system that will, in real time, allow us to bring to people's attention if something unusual is occurring on a video monitoring system.
I built a nice solution for you. I should talk about that sometime. I think that...
Well, you didn't bid.
Yeah, exactly. I think, Chris, the other thing is that human capital and the scarcity of resources, this is true whether it's in government or across the commercial space as well. In the cybersecurity world alone, you know, they're talking about tens of thousands of job openings. And, you know, I tell my daughters, hey, listen, you want a good job, cybersecurity or genomics, okay? And you're going to have a career and everything's going to be just fine. The problem, I think, or the opportunity for machine learning is to take that tsunami of data and discover patterns, because machine learning is only about pattern recognition. You know, if I tried to distill it to its essence, and some might debate about that, but it's just about pattern recognition. So if you can find those patterns in the data, and if you can help the human find them more quickly, then the human is going to be much more productive, and they're not weeding through all of this tsunami of data. I think the second thing is that, which I don't think we've still done a good job yet, which is if we can represent that data. If we had machine learning techniques that could also do really good visualizations, the human cortex is still phenomenal when it comes to visualizations and understanding visualizations, okay? What we've not done is that very good experience with the machine and the human yet, but if we can do that and continue to unlock the capabilities of the humans, that also, I think, will make machine learning and artificial intelligence more effective in the workplace, and that's the real value.
If I can comment on that just a little bit, if you guys Google Nicolas Cage correlation with swimming pool deaths, you will actually see that the number of movies that Nicolas Cage was in from like 19 whatever to like 2000 actually correlates with the number of thousands of people who died in swimming pools. And this is one of the issues with machine learning. You can get unintended correlations. Just because you have correlation doesn't mean causality. Like the umbrellas are causing it to rain, you know, that kind of thing. And how this manifests itself in cybersecurity is this data labeling thing. And I've actually looked at a number of companies who they can take in data, they can do correlation, and they'll find, they'll say amazing things like, wow, the number of FireEye alerts that correlate with attacks is really high. That's what it does, right? It detects attacks. So this data labeling thing is a really, really difficult problem. And what makes it worse in cyber is it's so easy to sense things now. We have sensing from everything, right? From the cloud, from the network, from IoT, from our cell phone devices. And you know, we're required to do these kind of things. So you can get these unintended correlations giving you false correlations, which kind of takes us off our game a little bit.
And if I could take that one more point, and here's where Chris loses control of the panel.
That's where it works.
Here's the danger between AI and machine learning, which is false positives, right? So right now, we're not very good. We've got technology that we think we can give an analyst the top 20 things she should look at, but we know that maybe 5 or 10 of those are false. That's not bad, and it's especially a lot better than giving you 1,000 that have 500 bad things, right? And so that whole false positive rate, I think, is really the critical thing too, and trying to keep that down gets really tricky. And we also are now in this world where you're not going to have labeled data sets, and I know that that's an area that Bill's doing a lot of work in as well. What we've decided to do, and another shameless plug for some of our technology, and we have this columnar data store called Vertica, which is in use at places like Facebook and Uber. Every time you book an Uber ride, it's going through Vertica. The nice thing is it can process literally trillions of events in a very, very short period of time. So what we're doing is we've made the basic assumption when it comes to the enterprise that the perimeter is breached. You're under attack and you are infiltrated. How quickly can you find that? And then the question is, when it comes to insider threat, one of the things we look for are compromised credentials. And so we've been using some of the machine learning techniques of feature extraction to see, can we understand what a compromised credential looks like, and then can you find that pattern in the sea of events that are flowing in from DNS and NetFlow and all these other things. Not labeled data, we're just now trying to match those patterns. And we're getting some pretty good results right now. The false positive rate is still a little higher than I'd like, but we're going to have to get to the point where we can work with unlabeled data because we'll never have enough labeled data, right, Bill?
Yeah, I think if I love the conversation. If I could maybe steer it in a little bit of a different direction here, we're talking a lot about machine learning, and it seems like that's kind of where we are today, and there's not so much of the true AI piece of it, which is kind of interesting. And so I guess I might ask the question. We're looking at things. Read an article where MIT was able to hack Google Vision, which was artificial intelligence vision, and it's intended to be developed to classify things, to be able to classify weapons based on a visual image and things like that. And MIT was able to trick it into classifying a turtle as an assault weapon. And so if we're doing that today, and if we're talking a lot about machine learning, it seems to be about pattern recognition and things like that. Is the panel aware of anything that we're doing in predictive capabilities in moving the needle forward? And if we're not doing it today, maybe how far away from that are we?
So one of the DARPA programs is around model intelligibility, I think they call it. And so one of the things we haven't talked about so far is that we talked about pattern recognition. So machine learning, when it's running, it's just doing simple inferences. It's almost trivial. It's just it's a classifier. Is this A, B, or C? All right. And the problem is that model has to get trained. The training of that model can take days or weeks, and for some of these papers you'll see published by some of our best institutions in the world, that grad students spent months training a single model. All right. But no one actually understands what the representation is within that model. And so there's this whole adversarial AI role now, right, where MIT's the most recent, but others have shown that you can create features that have nothing to do with what the model thinks it should be and fool the model into thinking that this turtle is an assault weapon. It's actually quite clever if you Google that. It's really interesting. And it's because we don't understand how to interpret the model itself. And so we've been doing some work there trying to understand how those features, all those compound features, can relate to the real world. Big DARPA program on that. I think we're going to have to crack that nut before AI ever becomes really prevalent, because would you trust something that you don't actually understand why it just made that recommendation?
And so, Dr. Vanderlind, maybe not to put you on the spot, but being involved in so many programs in IARPA, our audience is primarily some value-added reseller solutions providers, systems integrators, and a handful of vendors out there as well. Are there any programs that the room should be aware of that are working on advancements in these areas? Or I should say, what programs might we be able to talk about? I know they're out there. What problems might we be able to talk about that they should be looking into?
Well, yeah, I'd like to follow up on what Rich said about the adversarial AI, because we feel that is a very important thing. I mean, consider you're in a self-driving car, you're coming up to a stop sign, someone has altered the stop sign in a way that's imperceptible to humans, but convinces the car that it's not a stop sign, and you roll into the intersection. Definitely a major concern. And so we have some programs that are addressing that. One of our programs is called Microns, which is essentially reverse engineering neural tissue in the brain to determine what algorithms are used by the brain so that we can develop better machine learning algorithms. And we are looking at the adversarial aspects of that, say, looking at the cerebral cortex and what algorithms there could be approached in adversarial fashion. The other thing that Rich alluded to is understandable AI. Right now, the algorithms are often a black box because you didn't devise them yourself, you just trained them using a data set. And so that raises some serious policy issues for the federal government when you don't understand why you're making a decision. I mean, suppose you're a law enforcement officer, you want to go to a judge and request a search warrant, and the judge says, well, how do you know this is the right house to search? And they say, well, the AI algorithm tells us it's a 99.9% probability, but we don't understand the algorithm.
Nicolas Cage put in another swimming pool.
Yeah. So I don't think the judge is going to like that. So there is a program at DARPA run by Dave Gunning called Understandable AI, and that should hopefully address some of those questions.
Yeah, just a couple comments on that. So when we have AI deployed, it's going to get attacked. It's going to be another thing that hackers are going to use against us. So these kind of subtle ways to confuse things, it might be a way to come in. And it's standard practice for any adversary who wants to break into a target to figure out what the defenses of the target is, whether it's a certain set of vendors, a prevalence for open source, a prevalence for patching, prevalence for using AI. They're going to model that and figure out a way around it. And then another one, something that was said early on is some of the words you used about finding patterns and bringing those patterns inbound, and also doing anomaly detection on what's there. These are two different things. If you do anomaly detection on internal traffic, all you're really going to alert on is things that are different, right? Things that are different might not necessarily be things that are bad. It's not, the shadow brokers. It's not there. It's something, but it's really good to show an analyst. At the same time, though, you still need to bring in threat intelligence. The things that we know are bad, let's just go hunt for these things. And that's current state of the art right now. And that's definitely something. If you don't have that capability in your vendor set, your product set, your customer set, that's not cutting edge. That's kind of what almost every major SOC is doing right now.
Very true. Very true. If I could go back, the concept of autonomous vehicles was introduced. I'm going to ask one more question, and then again, we'll open it up to the floor, I promise. But I thought there was a very interesting perspective here from a societal and a political perspective. You can't read about artificial intelligence without seeing this grand debate that's going on between Mark Zuckerberg and Elon Musk and Bill Gates and Jenny Dearborn of SAP. And so there was a fascinating perspective in conflicting articles that I read. And there's one that was Zuckerberg's perception that we can reduce the amount of fatalities due to car accidents with autonomous driving. And then Jenny Dearborn took an alternate perspective that pointed out the fact that, well, how do we manage when a machine is making a mathematical decision between saving the driver of the car, let's say it's going to get into an accident, by driving into a crowd, or by running into a tree, or running into head-on traffic, which may, again, injure someone else outside of it. And so I thought it'd be interesting from this panel to get perspective, and I'll start with Ron and work the way down, on what's government's role in all of this, and who makes that decision.
So that's a great way to frame it, and science fiction is grappling with that. We've seen movies kind of grappling with this. We've seen society grapple with this. There's many things as a society that we're not grappling with yet. Privacy is one of them. The role of autonomous decisions, making decisions for us. Even though when we all came here today, Google and Waze probably had an influence on how we got here and how we went, and we seem to be okay with that, right? No one's questioning the Google engineer. The way I see it is this: when I was in school, we learned the ethical problems of how much should you spend on a brake pad, right? If you spend too much, you can't make money. If you spend not enough, people die. Well, we're just changing brake pads for AIs. Like, how much should we train the AI and to keep people safe and do these things? So, we're not going to solve this problem. The government's not going to solve this problem. Our kids are just going to code it, and we're going to get whatever they code.
That's a scary perspective. Mine's only 4, but it's still kind of scary. So, Dr. Vinderland, do you have a comment?
Well, this has reminded me of that Tom Cruise movie, Minority Report, where they were able to predict whether you would commit a crime before it occurred, and they would actually arrest you before it occurred. So I think we may be heading in the direction where we can make those sort of predictions, and it's very troubling, certainly. And I think eventually we'll need legislation in these areas. But yeah, there's a lot of unanswered questions.
And so, Rich, maybe if you could put a little bit of a spin on the same question, because I really want your perspective, period. But the thought came to me, it's going to require such, I think, diversity and perspective and input from so many different resources. Again, I'll ask the same question to you. What do you view government's role in making this decision?
Well, first, Ron made a great point about our kids are going to create the software. And of course, they're also concerned about their privacy, right? So they'll be equally concerned in the software they create. Okay, that's sarcasm because that didn't get translated. Didn't Asimov figure out the 3 laws of robotics? Didn't he fix this? Right. Okay, so I think government's role is very interesting. Equally important is the financial role in the financial industry. So you gave that quick little example of there's going to be a mathematical equation that gets run, and we're going to decide, do I kill the driver, me, or 3 people on the sidewalk, okay? That decision has to be made, right? When that happens, what will the insurance companies do? And what will be the cost to get future insurance? There's a little known, not a very well-known fact, but in Silicon Valley, you can see the Google cars all the time. And They've been in many accidents. They tend not to talk too much about that. And typically they're in an accident because they've run their mathematical program that says, I have enough time to stop at this stoplight, therefore I should. And the human driver behind them says, this is California, and if it isn't orange, I'm going through it. Okay. And so in a world where you have a mixture of thought process, you said rationality earlier, I'm not sure we even know what rationality means, but when you have these rational actors that have different cost-benefit ratios, you're going to have systems that collide, okay? And then coming back to the government role, here's the thing that I'm concerned. A lot of you probably get pressured to do something with open source, right? And there's value in doing certain things with open source, don't get me wrong. But there's two things you have to remember about open source. And there's a lot of open source machine learning and artificial intelligence frameworks right now, whether there's a Google or framework, there's a whole bunch of them out there. And I bring this up because, first of all, open source is not free. If you're going to use it, someone's got to understand how to use it. Second of all of the attack surfaces of that are well known. And so you just brought it into your product. Okay? Do you want to be liable for that? It's completely open, right? So anybody gets to explore that. And I think government's role, actually has to be a little bit different, which is figure out in those areas where investments are going to be made, both with industry and academia, to keep closed source. Because some of these things you don't want to be open because you're trying to minimize the attack surface. So I think it's a rather different view of what government's role needs to be, but from a technology point of view, I think we have to rethink some of these things because the risks are significant if someone is able to fully understand the exploitable attack surface of the software.
You bring up a great point. I'd love to unravel that thread a little bit, but again, I promise I will open up questions to the floor here in the aspect of the legal perspective around each of these different decisions that are going to have to be made. The insurance perspective that will certainly change the insurance paradigm and things like that. So thank you for that. Again, I do want to open it up. It looks like we've got one question in the back.
You were talking about the role of government. Landon Dyke from the State Department. Hi.
Hi.
One of the questions we're grappling with, and maybe you could give us some advice, is the rational actor component you were talking about. We're talking about it here in the U.S. Obviously, there will be other car manufacturers down the road that will have their own AI in their vehicles as well. Germany, Korea. They also have rational actors that are doing AI, but their culture of who you would want to save is completely different than what our culture would say, who would you want to save? And so when we start bringing AI into the public sphere where it could actually affect the public, how do you suggest we take care of interacting with other importers and exporters of AI into our society and culture?
That's like a simple question to get things rolling. Huh?
We'll start with a layup.
You know, we can't even solve the problem in the States, and now we've gone global with that. So you brought up a really important point, which is the multiculturalism, all right? But I think actually it's more complicated than that because if you think about the people who are creating AI systems today, it's multicultural, right? Here in the States, every one of those nations that you just talked about have individuals here who are building those systems, right? So you're already beginning to get that multiculturalism in the systems themselves. How government chooses to create standards and policies, really interesting question. And I think this has been the problem of the last 20 or 30 years is that government and the legal system is well behind where technology is, right? It lags 1 or 2 decades. And I'm not sure how we're going to handle that one. I don't have a good answer to that. I'll toss it to Ron.
I just bought a car, and it has a setting for number of links that you can follow. And I'm imagining like a setting for number of people on the sidewalk you don't want to kill. But all in jest, there's so many other issues we're grappling with as consumers. Privacy, like when I buy something, when I'm at Facebook, what happens to my data? If I'm in Europe, we got the GDPR stuff to worry about. You've got the complexity and vulnerabilities, right? If I'm going to buy an IoT thing, we just had cameras. The report kind of came out that a lot of cameras have vulnerabilities that we thought we were fixing. AI just kind of adds to that. It's another thing that we don't know about, even though what we deal. Anybody here can tell me how Waze works, like on the back of a napkin? It's insane. Just how much complexity is out there. AI is just adding another thing. I don't think the government is going to be able to regulate it. I don't think as a society we're going to be able to determine what we can do to consume it.
Well, I'm an engineer, not a lawyer, but it seems to me that one of the important factors here is what is legal, what the laws are. I mean, it is legal to drive on the road. It is not legal to drive on the sidewalk. So if, say, a drunk stumbles into the road, are you going to swerve on the sidewalk and kill innocent people? I think the default would be, all other things being equal, that you would stay on the road where it's legal to drive.
But I do predict massive lawsuits after the first. There was. My office in Silicon Valley is in Sunnyvale, and it overlooks NASA Ames Research Center. And after that unfortunate fatality of the Tesla vehicle in Florida, right, where the white semi-truck against the white sky background, the Tesla didn't see it, right, and the car hit the truck. I watched for 3 months while they're out there on those run race testing with big trucks and Teslas, all the new algorithms, okay? It'll be interesting to see how many significant lawsuits we have at the beginning. That may shape what goes on legally faster than government's able to do that, because you just won't be able, some things will just be exorbitantly expensive to deal with.
I think society is going to be interesting as well, because we seem to be a society that adopts technology at the risk of security or things like that. We care about features, functionality, and benefits, and security is an afterthought today already. And so I think there's an interesting angle of it that you have to think about there that just gets exaggerated, if you will. And so we've got a question in front here.
Yeah, my name is Bill Zook. I'm with Logarithm. This is not dealing with the technology. This is dealing with artificial intelligence, and I've been following this since I was in my 20s and the 80s. The real question I've always thought, and this is from someone who has an academic background in psychology, is that we're trying to get machines to think like people. We are getting to, there's that one little thing. Let's make it in the contracting world. You got two contracts. They look almost identical. The one that looks economically better, the contracting officer goes, no, I'm going to take the one that's slightly worse for something in my gut. Or in the real world for us as individuals, we walk into a car dealership. Dealership A gives us a deal. We look at the deal, and that little voice in the back of our mind or in our gut says, not today. Let's go down this other one and see what the other guy's going to say. How are we ever going to overcome that in an artificial intelligence and machine learning environment when we're basically using truth functional logic to a large part and very large scales?
So I think so a lot of my comments, I just read Rise of the Robots and Robopocalypse back to back, right? So one's like true nonfiction and one's fiction. Plus, I watched a lot of Star Trek, right? And I've seen this happen, right? If you get a new piece of technology as humans, if you're a geek, what do you want to do? You want to play with the technology, right? If it works like the word translation one and you get great results, I tend to believe it, right? So we have this sort of confirmation bias in it, right? But if you get really good results and you don't understand it, like in the late 90s, there was a worm that came out that used the SNMP protocol, and it crashed computers. And all the anomaly engines in the world said, this is bad, but everybody ignored it, right? So after that, they started kind of paying attention. My point is, we're going to install these things, we're going to look at the results, and if it works, we'll probably do more of that.
Two quick things. Herbert Dreyfus, the philosopher at Berkeley, read his book, What Computers Still Can't Do. The second thing is that I had the opportunity in 2009 through 2012 to work on the DARPA Synapse program, which had the very humble goal of building an electronic brain that would fit in a shoebox and run on 100 watts.
Is that sarcasm again?
Yes. After about 2.5 years into it, we realized it was all about the software, not the hardware. But at the time, we were working with the Center for Computational Neuroscience at Boston University, which has some of the most talented neuroscientists in the world. And I'm an electrical engineer and a computer scientist background. One thing I learned about the neuroscientists is if you put 7 of them up against the wall and ask them, how does the brain work, you'll get 21 different responses. Okay. The second thing is that a lot of them describe the behavior of the human brain in these very complex differential equations, which later on, with the rise of GPUs, we were actually able to simulate, and we showed that almost all models of the human brain that people had created aren't stable. So that means they're wrong, okay? Exactly. And so which gets me back to your point. Is your intuition, because that's what you're really after, insight or intuition, is your intuition just because your brain, which has a tremendously, I mean, one thing I did learn was it is amazing what we can do in this neocortex, right? It's roughly the size of a dinner napkin from a nice restaurant, okay, as opposed to McDonald's. It's 7 business cards thick, right? And every song that you've ever sung, every person you've ever loved, I mean, it's all in this one little tiny sheet, all right? It's just incredible in terms of how powerful it is. But it's a finite resource. So I've often wondered, is our intuition just because it's a finite resource? There's something bubbling back there that's experienced, but you've overrun most of it, and so you're just getting the remnants of it. Whereas if you had a system that had full knowledge and full recall, it wouldn't have intuition, it would just have knowledge, right? But we still haven't had an AI system that's written a Shakespeare book, right? We've had RNN, recurrent neural networks, that have mimicked Shakespeare, but no one's written a bestseller yet, no one's written a symphony. They've mimicked, but they've not written one. It's that creativity element that's missing as well.
Watson, I guess, is doing a lot of things in culinary areas where they're actually creating meals and things like that. So it's kind of interesting in the different places they're using it. But Bill, I'll let you take a moment to answer it. I'm wondering if IARPA has any programs or any focus on, again, I think empathy, I think emotions, I think chemicals in the human body when we start talking about this. Is IARPA looking at any of this sort of emotional intelligence?
Well, yeah, surprisingly, we actually do have several programs in the neuroscience area. Now, just my thought on intuition and gut sense of things is that your brain is, at the subconscious level, interpreting small pieces of data that you were not conscious of. So we had a program called the TRUST program, which was designed to be sort of an unconventional polygraph in which you would instrument the questioner, not the subject. And the idea was that the questioner had a subconscious level of knowledge about whether someone was trustworthy. And in fact, it's also a slightly different question as to whether someone's lying or whether they're trustworthy. Your car salesman may tell you the truth, but he's still not a trustworthy person to deal with, or vice versa may be the case. So the TRUST program, eventually we discontinued it because we got a positive result, but not enough to really be useful. But we also have a program called SHARP, again, neuroscience related, looking at ways of increasing a person's fluid intelligence with all kinds of interventions, pharmaceutical interventions, electrocranial stimulation, which actually works, although you're not going to wire me up to that thing. Interestingly, and it's a computer-based game training type things. The things that actually were the 2 most effective ones were the ones your mom told you when you went to college. You get plenty of sleep and good nutrition.
So we have time for at least 1, maybe 2 more questions, and then I do want to bring it back for a question that I have prepared.
On the left.
Do we have oh, there we go. Sorry about that.
Thanks. So, Dr. Vanderlyn, you had talked about something to do with the judicial system and relying on AI and saying, the judge will never rely on this. I think the opposite in a way, because you have the story of, sir, to a reasonable degree of scientific certainty, do you believe, and there's no legal definition of reasonable degree of scientific certainty, and yet people get convicted all the time based on a reasonable degree of scientific certainty. If an AI comes up with something that says 99.95%, that's going to overwhelmingly trump that eventually, just because the theme is that AI is going to be smarter than us, and it's going to be more reliable. It will drive our cars. It will convict our people. What are we doing to keep the judicial system from adopting that? Does anybody have any?
Well, I think we do still need to understand it better because, as has been pointed out, academics have this parlor game where they see how many pixels they need to change in an image to fool a classifier, and it isn't very many. I was reading yesterday about 1 pixel attack that came out of MIT. They can look at what's called the gradient of the cost function to manipulate the image, so you can change just the 1 or 2 least significant bits of the image, and that will fool a classifier because it's affecting the weighting function that the classifier is looking at. So you'd have a picture of a cat, looks like a cat, it's modified. It still looks like a cat to me, but the classifier thinks it's an ostrich with 99% reliability. So unless we get a handle on really understanding what the AI is doing and how to defeat these sort of adversarial attacks, we're not going to be able to use them reliably in a legal setting.
Understanding that that kind of unreliability is what we're talking about. It's not about whether you as an expert would adopt it. What are we doing to keep people who are less savvy from adopting reliance on AI techniques?
I don't think I've seen the campaign or the sticker to say "Don't trust the AI," But I mean, we're doing it right here, right? We're having the conversation. There's books that have been read. We got Elon and a brief history of time gentleman saying, AI is bad. But what are we doing? We're not saying, hey, let's not code AIs. We're not outlawing those things, and we haven't even done a really good job defining. What is an AI and what's an algorithm, right? If an algorithm is going to make decisions about life and death, I mean, Underwriter Labs, there's some liability. It's an evolving process, but I don't think there's an active campaign not to do anything.
And the only thing I can think of, once again, I'm not a lawyer, but from my ancient studies of the Supreme Court and the process that happens there is that will get submitted to court and it'll get appealed and eventually the Supreme Court will rule on it, right? And so depending on who's sitting in those Supreme Court seats at that time will determine whether or not it's a viable test that can be used to generate evidence, right? Just like we have dozens of other tests, some of which are legal to use in a court proceeding, many of which are not, right? That'd be my guess, practically speaking.
So we've got one more up front here.
Vince Ritz with CSRA. Since I see there's going to be a lot of legal suits that come up out of this AI market, what's going on as far as flight recorders and being able to play back the models to show the decision that was made given the inputs and sensors used that can show a court of law or whatever else, why the machine did what it did? Anything going on there?
So we have a small project on model intelligibility that is first of all just trying to understand why the model predicts what it predicts. And in the area of cybersecurity, as I mentioned earlier, it's looking at all the features that have been collected, IP destination, source IP addresses, things like that, right? So that when it makes a recommendation, it will say, here's the features I used, so the analyst can decide if that makes sense or not, right? But in terms of,
Visualize it so lay people can understand.
Oh, without a doubt, without a doubt. And then the other question you talk about is telemetry as well, right? Because how do you know someone didn't spoof the model during the model training process, right? And that's another place where you can now attack, is you can attack during the training process itself. So I don't know of anyone who's doing anything around that sort of telemetry. I don't know. Bill, do you know?
I don't.
Okay. So I think we've got about 5 minutes left here. I want to wrap up, and I'm hoping we can have a little bit of fun with this question. And so I talked about Mark Zuckerberg's perspective already today in that he believes that it's going to advance civilization, and this is a very good thing. And then you have the Elon Musks of the world that have been out there over and over and over again with doomsday predictions, the greatest risk we face as a civilization. I just would be curious to hear from each of you, where do you fall in that spectrum?
So I want the Star Trek world, right? I want a world where, everybody has a chance to be a better person, where their cost of goods is low and things are generally safe. We have to worry about things like driving and medicine and things like that. Now that's a fantasy world, right? So what's likely going to happen in the next couple of years? We're going to have robots replace blue-collar jobs, which is probably going to create an anti-robot type of voter class, which is going to then put pressure on all this conversation that we're talking about. So I see something along the lines like a net neutrality act for AI. There's going to be some sort of public debate about how much we're going to have of this and how much we're not going to have of this. The rest of the world, who knows what's going to happen?
Bill, very interested.
Well, I'm not so much concerned about AI is taking over the world as intelligent entities because, as we've talked about, they really don't think like people. They're more tools that people can use. But I think whoever has the best AI will gain a dominant market position in the world. And so where you look to have the best AI, you look to has the big data sets. And right now that's places like Google and Facebook in the US. Overseas, there are other countries which have much more limited privacy rights than in the US. And I'm concerned that some of those countries may get ahead of us in AI just because of the access they have to big data.
There's some line of questioning that I had here around this being the next arms race, and I'd love to continue that conversation, but we'll run short on time. So, Rich.
What was that classic line? Open the pod door, bay, how? What's interesting, I think the other aspect of the whole Mark and Elon is like others, and I tell my kids all the time, just because Twitter exists doesn't mean you need to post to it all the time, okay? Stop tweeting. There are a lot of people that applies to, not just those two. But anyway.
Who would that be?
I think it was Gordon Moore who said that as engineers, we tend to be incredibly optimistic about what we can accomplish in 1 year and incredibly pessimistic about what we can do in a decade, and that's probably true here as well. I'll offer this pragmatic piece instead. I'll kind of build on what Bill said. For each of you today, I think machine learning has advanced to the stage now where you should be doing projects with your clients. Don't try to sell them that this is going to be the panacea that will solve all their problems. But start with some projects. It reminds me back in the 80s when we were building the first relational database systems on Unix, HPUX at the time. You know, that was when Oracle was this tiny little entity that no one had ever heard of. And so at that time, everyone's database is set on a big mainframe, right? It was all DB2 or what was the other thing? IMS. But we built this whole other infrastructure, but we started one step at a time. I would say that would be my advice is start there. I'm not too worried about AI because partly what Ron said, my kids are writing the code. You have a hard time getting your apps to work on your iPhone, let alone an AI system. So I'm not too worried about it, at least in my lifetime.
Well, I want to take a moment to thank the panel for the participation today. I certainly enjoyed this.
Thank you for coming.